Let's talk about the capital asset pricing model, CAPM, and risk premium. So what is the risk premium? Let's use an example. How much you are willing to pay for fire insurance? Let's say your home is worth $250,000 and you see very small probability of a fire in your home for the next month, 0.1%. So expected loss for the next month is $250,000 times 0.001, so $250. Now you have insurance for your home. That insurance says that if you pay some premium, when there's a fire in your home, the insurance company will pay for that damage. Given insurance contract, how much you are willing to pay for that. Someone will pay much more than $250 to avoid any uncertainty like this. So what determines how much they're going to pay? It will be determined by how much they are averse to risky situations. We can talk about premium you wish to pay to avoid risk or uncertainty in the future. That can be interpreted as an insurance premium or risk premium. Let's use our carry trade example to talk about the risk premium more precisely. In our previous example with the carry trade using forward, let's say Miss Sell is the treasurer of a large US corporations expecting to earn 10 million pounds 30 days from now. So we have Mr. Buy and Miss Sell. And be careful, Miss Sell is the treasurer of a large US corporation. It means this company will measure profit and loss in dollar terms. Let's assume that the market expected spot exchange rate in the future at T+1 is $1.56 per 1 pound. If the market expected spot rate is indeed realized at T+1, Miss Sell would earn 10 million pound times 1.56 pound will be cancelled and she will get the $15.6 million. Miss Sell indeed agrees with this mean forecast. This is about expectations. You repeat history 100 times in your brain, mean realized value will be something like this one. But in actual practice, you just have one shot for the future. Any value could be possible from the distributions of the future exchange rate. So Miss Sell is still worried about the possibility of the unexpected pound depreciations against dollar. If there's an unexpected pound depreciations, that means even though Miss Sell is sure to get 10 million pound, in dollar terms will get much lower dollar value because of the pound depreciations. For example, she will get much less dollar profit than 15.6 million when the future exchange rate is indeed $1.4 per 1 pound, then she will get only $14 million. Miss Sell is willing to sell pound forward to remove this FX risk at the forward rate lower than the market expected spot exchange rate, which is this one, because she is worried about, for example, something like this would happen in the future. Let's say the Miss Sell is willing to offer the 1-year forward rate slightly lower than market expected rate, and Mr. Buy is willing to do the counterparty of the contract, buying pound forward in this example. Why both could be happy while the forward rate 1.5429 is lower than market expected future spot rate? From the previous slide, we know that on average, Mr. Buy will earn from implementing buying pound forward when he has this inequality on average. First, Miss Sell would be so much worried about getting lower, even lower than $1.5429 per pound in the future. For example, if the realized future exchange rate is $1.4 per 1 pound, then Miss Sell lose further without forward contract by the difference between forward price and the future spot exchange rate per every pound. By selling pound forward, at least Miss Sell is able to remove these kind of risk. In other words, Miss Sell is selling pound forward as an insurance. For that reason, she is willing to pay this difference as the insurance premium on average to the buyer of the contract, Mr. Buy. Now, Mr. Buy is taking the currency risk and obtain the difference for providing this insurance service to Miss Sell. We can call this as a risk premium. So we have one number here, 1.56 minus 1.5429. The difference could be interpreted as the insurance premium to Miss Sell, And the same thing could be interpreted as a risk premium for Mr. Buy. Well, this is just an example. What determines the sign and magnitude of the difference? We need an asset pricing model. This is one of the reasons why we are using CAPM in the next slide. So what is the CAPM? William Sharpe earned the Nobel Prize in Economics in 1990 for his contributions to the theory of so-called capital asset pricing model. This is the exact equation for CAPM. We have excess return for each asset I in the left-hand side. In the right-hand side, we have beta I measuring covariance. Sigma m squared is just there to standardize the unit. So the important thing here is the covariance times market excess return. So how much you expect to earn when you invest into market portfolio, market index over risk-free return. That is the implications of the ERM minus RF. Now, this number should be positive always because investor will expect to earn something on average by investing into more risky asset. If this becomes negative, for example, that means on average, it's better to invest into risk-free bond rather than risky stock market index. That doesn't make sense. We can always say that the expected excess return from investing into market should be positive. Well, be careful. That doesn't mean when you invest into stock market, you get positive profit all the time. We talk about this on many times, the difference between expected excess return and realized excess return. Expected excess return means on average, if you repeat history for 100 times in your brain, you expect to earn something like this. But in reality, you just have a one shot for the future. Anything could be possible. Realized excess return can be positive or negative. It just means it's risky to invest into stock market. There's no guaranteed profit. Anyway, excess return or risk premium for each asset I will be determined by beta I times ERM minus RF. Now, ERM minus RF is same to all assets. Therefore, beta I will determine how much you are going to ask for the compensations from investing into certain asset. So beta I is the essential element determining risk premium in CAPM. What is the risk premium in CAPM model? Risk premium on asset I or strategy I is the amount by which the expected return on asset I is in excess of the risk-free rate. So usual interpretation would be when you invest into risky asset I, how much you expect to earn more than risk-free return you get from investing into default-free bond. That is the definition of the risk premium. And in CAPM model, what is the risk on an asset I that commands a risk premium? Investors are only rewarded for bearing systematic risk, the type of risk that cannot be diversified away. When you form a portfolio, you can diversify certain idiosyncratic risk in your portfolio. We'll talk more about this one in topic 4. What is the systematic risk of an asset in CAPM? If CAPM is true, systematic risk can be measured based on the covariance between each asset's return and the return on well-diversified portfolio, for example, market index. Then how do we interpret CAPM beta? Investors ask a positive risk premium for holding an asset, investing into an asset with positive beta. Given positive market excess return, positive beta implies you ask positive risk premium for investing into that asset. In words, investors regard an asset I as a risky one if the asset I's return is negative when the return on the market portfolio is negative. This is the meaning of the positive beta. When the bad things happen in the market, if your asset gives also negative return, you feel investing into that asset is risky. So before investing into that asset, you will ask some compensations for your investment. So this is the risk premium you expect to earn on average by investing into that asset. Let's use an example. Talk more about the meaning of beta. First of all, the asset with the higher beta is more risky. For example, let's say we have an asset with the beta A is equal to and an asset B with beta B is equal to 1. When the market portfolio RM lose 1%, the asset will lose 2%, while the asset B lose 1%. So when the bad thing happens, you get more loss by investing into asset A. So you feel the asset A is more risky. Because of that reason, you will ask more compensations when you invest into asset A. So higher beta means you ask more premium on average. What about an asset with negative beta? Let's say an asset C has -5 negative beta. This indicates that when the market portfolio loses 1%, the asset will give you 5% profit. That's the meaning of negative sign, negative covariance. So you can interpret this asset as an insurance for the market crash. When the market goes down, this asset will give you positive return. So given positive excess return and negative beta, the risk premium for this asset will be negative. So we can certainly get the negative excess return for certain asset because this asset could be insurance to you. We don't have this one for market. If this is negative, no one is willing to invest into stock market on average. But for individual asset, we can certainly have this case. Normally, safe haven asset gets higher return during market crash. So those safe haven asset could have negative beta. Anyway, an asset with zero beta and non-zero standard deviations. This means this asset has zero covariance with the market return, but it has idiosyncratic variations. This zero beta asset has zero systematic risk while it has idiosyncratic risk. Then ERI should be same as risk-free rate. There is no reward for taking idiosyncratic risk in CAPM model. Well, this means if you only invest into asset I, on average, you're not gonna get any premium for your investment. We are assuming here every investor should invest in portfolio, not individual asset with idiosyncratic risk. We can say that investors should not be rewarded for bearing idiosyncratic risk, since this uncertainty can be removed through appropriate diversification easily. Investor will get rewarded for taking systematic risk. We'll talk more about this one in topic 4. Remember in UIP UH case, we talk about what is the assumption we need to get the unbiasedness hypothesis. At the time we said the investor could be risk neutral. They don't ask any compensation for taking risk and it's too extreme. Another case would be FX risk is the idiosyncratic risk. That means when you invest into risky asset, if the FX risk could be easily removed by forming a portfolio, then there will be no reward for taking FX risk. So we can justify no reward for FX speculations. Let's talk about some numerical example to understand CAPM more clearly. We want to compute, for example, expected dollar return for investing into Microsoft stock.
Let's say from historical data, we estimate beta of Microsoft as 1.49. How to estimate beta and also how to test CAPM, we're going to talk about these kind of things in topic 5. Anyway, often we use 20-year treasury bond as a proxy for risk-free bond. So from historical data of the 20-year treasury bond, we compute the average value and that's the 4.87%. And often we use the S&P 5 index as a proxy for market portfolio. So from the long run average of the S&P 5 index return and 20-year treasury bond, we compute market excess return as 7.95%. Given these numbers, we can use CAPM to compute expected dollar return for Microsoft. So expected return for Microsoft is equal to risk-free rate plus beta of Microsoft times market excess return, which is just 16.7%. Let's suppose beta of Microsoft is equal to 2. It means more risky than the 1.49. Then expect return for Microsoft is going to be, actually this is typo, 20.77%. This is also typo, sorry for this typo, 16.7%.
Now I want to make a note on a conditional CAPM equations. So we have CAPM equations with the conditional expectations. So what is the meaning of conditional expectations? When you forecast about the future, you use all the information available today. So when you invest into certain risky asset from T to T plus 1, you expect to earn this excess return, and everything will be a function of the information available to you today. So beta will be a function of time. Different time, you have different information, you compute different beta. And your market access return will be different because of the different information at time t, different forecasting model. We could think about the CAPM equation conditional on information set available to you. This is so-called conditional CAPM. So why I'm saying about this one? If you have good forecasting model for beta and market access return, you can use this form to compute the future excess return for investing into certain asset. If you believe the future is similar to the past, you can use usual CAPM model. But if you think time is changing whenever you get new information, you could get new and better estimate about the future beta and the future market access return, you have to use model like this conditional model. So I just want to make a note on that.